Hello everyone, welcome to my video on laws of exponents. This is a very important topic for secondary 3 or grade 9 math. And we actually saw these two properties already. We have 7 properties to go through in total. These are the first two. So we start off with multiplication. So whenever you're multiplying two monomials, these are called monomials, we'll see this later on. You have x to the m times x to the n. Notice that the bases here are the same. They're both x's. So whenever you're multiplying two monomials and the bases are the same, all we do is add the exponents. Okay, so we saw this in our scientific notation example videos. And if we look at this example over here, we have x to the 2 times x to the 3. So applying this property over here, this you guys have to have memorized, it's equal to x to the 2 plus 3, which is equal to x to the 5. Okay. In some sense, you could think of x squared times x to the cube as x squared is really just x times x, and x cubed is x times x times x. And you could count how many x's do you have. So here you have 2, here you have 3, so in all we have x to the 5. That's our final answer. Okay. The next property that we have is division. So if you're dividing monomials and the bases are the same, so we have x to the m, x to the n. Now, instead of adding the exponents, we subtract the exponents, and make sure you subtract the numerator by the denominator. The exponent in the numerator by the exponent in the denominator. So it's going to be x to the m minus n. So if we look at this example here, we have x to the 5 divided by x to the 3. This is the same thing as saying x to the 5 minus 3, which is just x squared. And once again, you could think of it as x to the 5 is really the same thing as saying x times x times x times x times x 5 times, there's 5 x's, over x to the 3, which is just x times x times x. It's very inconvenient to write it this way, but you could think of it this way. And then you cancel each x. So 1x on top with 1x on the bottom, 1x on top with 1x on the bottom, and 1x on top with 1x on the bottom. And we're left with just 2 x's on top, and that's why our answer is really just x squared. Okay, let's take a look at the other properties. Okay, so now we're looking at property 3. Property 3 is power of a power. This is one of the properties that students struggle with a lot, so be very careful here. If we have x to the m, all that in brackets exponent n, that's the same thing as saying x to the exponent m times n. In this case here, we're multiplying the exponents, okay? So if you look at this example that we have x squared, all that cubed, what you have to do is multiply the two numbers. So x to the 2 times 3, which is x to the 6. That's the answer. Be very careful. Don't confuse with property 1, the multiplication. When you have xm times xn, notice in this case here, there's 2 x's, whereas here we have just x. Here we add the exponents. So whenever you have 2 x's and you're multiplying, you add the exponents. Whereas property 3 says if you have x to the m, all that to the exponent n, so power of a power, namely there's only one x that's written, you have to multiply the exponents, okay? So make sure you distinguish the difference between power of a power and multiplication. So the following property is power of a product, product meaning multiplication. So here, notice that you have in brackets multiplication, x times y, and then we have all that to the power of n. That's the same thing as saying x to the n times y to the n. Essentially, the way I like to think of this is x has its own exponent over here. Let's put a little 1 in red. And y has its own exponent. There's a 1 here. We don't write them, but we know they're there. And what you're essentially doing is you're distributing the exponent n to everyone's exponent. Okay, so you're multiplying the n times 1, and you're multiplying the n times 1 for the x. So 1 times n is n, so you have x to the n, and then y, if you look at the exponent, it's 1 times n, so you get y times n, y to the n. Okay. So think of it as distributing the exponent to everyone's exponent inside the bracket. Okay, so let's take a look at an example. The example we have here is x squared times y cubed, all that squared. So what you're doing is you're just multiplying the 2 to the everyone's exponent. Okay, so this gives us x to the 2 times 2 is 4, and times y to the 3 times 2 is 6. And this is your final answer. Okay, let's quickly just look at another example. Example 2. This is a very common mistake that students make. What if we have 2xy to the 4? all that cubed. So in this example over here, remember, everyone has their own exponent. Think of it this way. The exponent of the y is 4. The exponent of the x, it's its own exponent. It's not the same as the y. It's not xy to the 4. X has its own exponent. It's not written. So in the beginning, what I like to do is write the exponents myself. So I put x to the 1, y to the 4. And don't forget the number. This is where students make this very common mistake. 2 has its own exponent as well. So I'm going to write it on the 2 as well. So it's 2 to the exponent 1, x to the exponent 1, y to the 4. Think of it this way, and you'll avoid making mistakes. And now what we do is we multiply the exponent here to all the other exponents. So you're going to multiply the 3 with the 4, the 3 with the 1, and the 3 with the 1. This gives us 2 to the exponent 3, x to the exponent 1 times 3 is 3, and y to the exponent 4 times 3 is 12. Okay, make sure to simplify. 2 to the 3, we could do this on the calculator. We get 8, x cubed, y to the 12, and this is the final answer. Very common mistake. Make sure not to fall for this. Okay, so let's look at other properties. The next property is power of a quotient. So we saw power of a product, multiplication. Now we're doing power of a quotient. Quotient meaning division. So the property is x divided by y now. Instead of multiplying, all that to the m. Oh, sorry, I think I was using n. Let's switch that. X over y, all that to the n. It doesn't matter which letter you use. But essentially you do the same idea, where you think of x to the exponent 1, y to the exponent 1, and you multiply the n on the outside with everyone's exponent. So this gives you x to the n divided by y to the n. This is the property. Okay. So let's take a look at a quick example. What if we have x squared over y to the 4, all that to the 3? So what you have to do is multiply the 3 to everyone's exponent. This gives us x to the 6, 2 times 3 is 6, divided by 3 times 4, y to the 12. Okay. And if you're wondering, why aren't we subtracting the exponents here? Well, the reason being is that property 2 cannot be applied where we divide, because the bases aren't the same. On the top, the base is an x. On the bottom, the base is a y. If these were the same letters, then we could subtract the exponents, okay? Let's take a quick look at a second example. Let's use this one here. 2x cubed over, let's do 5y to the 4. All this to the 2. So again, I strongly encourage you guys to write the exponent, write down everyone's exponent, don't forget the numbers. So the 2 has its own exponent, there's a 1 here, let's write that in. X, the exponent is a 3. For the 5, the exponent's a 1, let's write that in. And y, the exponent's a 4. And now you multiply the 2 on the outside with everyone's exponent. You don't have to draw these lines because it gets a bit confusing. But this is the idea I want you to have. So the answer to this is 2 to the exponent 1 times 2, okay? So be careful, you're not multiplying 2 times 2, you're multiplying the 2 times the exponent, okay? And then you're doing the x, the exponent is 3, we're multiplying by 2, it's 6, divided by, again, it's not 5 times 2, you're doing 5, you leave the 5 at the base, and you're doing exponent 2 times the exponent of the 5, which is 1, so 2 times 1 is 2. And then y to the 4 times 2 is y to the 8. Okay, so if you're thinking of putting 10 down here, that's wrong. It's not 10, it's 5 squared, which turns out to be 25. So we have to just simplify a bit more. So 2 squared is 4, x to the 6, and on the bottom we have 5 squared, which is 25, y to the 8. And this is your final answer. Okay, let's take a look at the next property. So the next property, property 6, is negative exponents. This is one that students struggle with mightily, but it's pretty simple. So the property is x to the negative n, and that's equal to 1 over x to the n. Okay, so I kind of have a weird way of thinking of this. The way I think of it is, think of it as a 2-story house. We have upstairs and we have downstairs. Every number is written over 1, right? So we could think of this as x to the negative n on the top. He's upstairs. And since he has a negative exponent, think of it as him being mad. He's angry. He's upstairs and he's mad. So how does he cool down? He goes downstairs. So the x to the n was upstairs. What did we do? We brought him downstairs. And now his exponent is positive. He's happy. Okay. Think of it this way, and I think it's going to simplify the idea of negative exponents. So let's take a look at this example over here. We have x to the negative 2 divided by y to the negative 3. How do we get rid of the exponents? We essentially just flip it. Okay, so x to the negative 2, the x is upstairs and he's angry. His exponent is negative. What do? Bring him downstairs. And he's happy. So we have x to the 2 on the bottom. So the negative 2 went downstairs and turned into a positive 2. Same for y to the negative 3. Y to the negative 3 is downstairs. The y is downstairs and it's angry. It's angry downstairs. What do? We bring him upstairs. And now he's happy. So the y comes up and his exponent is negative on the bottom. Now on top, it's positive. So you're essentially just flipping, okay, to get rid of the negatives. And that's our final answer. The last property that we have is property 7, which is the zero exponent. So the zero exponent, we have x to the 0. Any number to the exponent 0, except for 0, is equal to 1. This one's nice, very easy, and on tests, this is always the first one that I look for. So let's take a look at an example, and this is a bit of a trick, so be careful. Let's write down two examples. We have 4x to the 0 and 4x all that to the 0. If we have 4x to the 0 and 4x all that in brackets to the 0, what are the answers here? I don't know if this surprises you, but the answers are actually different. This isn't the same. Because what you have to remember is that everyone has their own exponent. So here, at the first example, we have 4x to the 0. The exponent of the 4 is 1. So since it's 4 to the 1, x to the 0 is just 1. So this is the same as saying 4 to the 1 times x to the 0. This whole thing is equal to 1. So it's 4 to the 1 times 1. And what's 4 times 1? It's just 4. So the answer for the one on top is 4. Here, everything is to the exponent 0. So anything to the exponent 0, this whole thing is just 1. Okay. Another way of thinking of this is there's a multiplication here. We could think of it as 4 has the exponent 1, x has the exponent 1. And you can multiply the 0 on the outside. So this gives us 4 to the 0 times x to the 0, which is, let's write it down here. 4 to the 0, anything to the 0 is 1. Times x to the 0 is 1, and 1 times 1 is 1. So notice that your answers here are different, so be very careful. So a common trick that teachers like to give on a test is they like to put a big, massive, difficult equation. Okay, so let's say whatever I wrote on the board, this whole thing, let's put it all in brackets, and then they put exponent 0 on the top. So whatever's written in here, you could kind of ignore it, it doesn't matter. Since all this, whatever's written on the inside is exponent 0, what's the answer? Anything to the exponent 0 is just 1. Don't solve the inside. If everything to the exponent 0, the answer is just 1. And this is a common trick that teachers like to give on a test. Okay. So let's take a look at a couple of examples together.